The second part of Chapter 7 is going to get a little bit more specific with parts of the coastal regions and the zones. First of all, intertidal zones. Of course, we've got tides on our planet, partially thanks to the moon's gravitational pull. They can fluctuate every 6 hours. Believe it or not, we actually have tidal zones in the Great Lakes, although they are not nearly as expansive as the oceans, rather. In this area, you can see in the picture right here, of course, this is probably low tide right here, and then high tide would be back here as the water comes in. A lot of times as the water comes in, a lot of animals like those little sea stars come in with it, and they need to hang on in order to stay there. It's good that they stay there. They get sun there, they get food there in those trapped areas. The only problem is there's also predators, so they're easy prey at that point. So those organisms do have to adapt necessary to deal with daily salinity and, of course, moisture changes too, and really temperature changes too as the water gets more shallow and the sun comes out. Barrier beaches are something that actually protects our inlands quite a bit. This picture is okay on there. The problem with this is the picture is generally barrier beaches are on the mainland. This is a little bit more out of the coastal region. But what this shows is a really good example of a barrier beach. We even have beaches along the Great Lakes, of course, like this. If you go downtown to Bradley Beach, or really good dunes up in the Kohler area, which is by Sheboygan area, which you can see is this area, the water would be coming in here, and this is a huge protectant. We know beaches, of course, like I just said, even the small beaches around lakes, and what they do is they're sloping sand generally that protects the mainland. The organisms do have to tunnel or burrow into there in order to survive changes too. This is just an example of a barrier island, or it could be a beach for that matter too. The thing is, oftentimes if we have water coming from this region and then the mainland would be over here, actually I think we're drawing it the opposite way. Yeah, we have the ocean right here, sorry about that. And then we have a bay and lagoon over here. The nice thing is in the bay or lagoon area is we tend to get very calm water, and that actually prevents erosion from occurring in the ocean. The problem with this is a lot of times we build on here. You can see the little houses right there. And as we build on those, these things tend to move, and they're not real stable. Here's a really good example of a barrier island down here on the bottom. I believe that's off the coast of Texas, but you can see they've built on it. Again, the problem is they generally are not real stable. They're the first things to get hit by storms, and those sands are constantly shifting. So barrier islands are very narrow islands that are offshore from the coastlines. They do protect the mainland. They protect estuaries. Some are developed on. The problem is, again, the sand is constantly shifting. The good thing is if you live on that is you tend to have views of both sides of the water, which is absolutely something humans tend to love. Coral reefs, think of as great diversity. Coral reefs are deemed the marine equivalent of tropical rainforests. While they only cover about 1% of the earth, they are incredibly diverse in their animal and plant populations. Very slow growing, very highly diverse. I know that a lot of times the coral reef, like off of Florida, takes about 10 inches, takes about 100 years to grow. So if we destroy those, which unfortunately we're doing in a lot of cases, they don't grow back very fast, and we need that habitat for our plant and animal species. Their habitat for 1/4 of all marine species. They're very sensitive to two things, and that's temperature and salinity change, and they do require clear water. They're getting hit by global warming, which I'll talk about in a bit, but that leads to something called coral bleaching. The good news is about 300 reefs in 65 countries are now protected by a marine protection agency, it's called, which we'll talk about. So why do we really care about these coral reefs? So first of all, they help moderate the atmospheric temperatures. Coral reef, please keep in mind, is a symbiotic relationship between a polyp and algae that lives together, and the algae tend to give it color. They moderate atmospheric temperature in the respect that they're huge carbon storehouses because they're made of a calcium carbonate solution, or material rather. They act as natural barriers, protecting coasts from erosion. They provide excellent habitats. They support fishing and tourism businesses. A lot of people love to dive in there or snorkel in there. They provide jobs and building materials, and of course they can be studied and enjoyed like us. The problem is we're degrading them, and they're declining quickly. As we develop our coasts, as I said initially, we have a lot of people that live along the ocean, a lot of those pollutants go off and they wash off those nitrogen and phosphorus among industrial toxins into the oceans, and they're destroying them. We are overfishing these areas big time because, quite honestly, that's where the fish is and we need to eat, so we go after them. Warmer ocean currents do lead to something called coral bleaching. That does not mean that we're pouring Clorox bleach into the ocean. What that means is that the symbiotic relationship between the polyp and the algae, which they both need each other to live, the algae dies and the food source therefore for the polyp dies and it's gone. Both die, and of course it turns generally white because we don't have that photosynthesizing plankton in there. We do see that it does help with increasing ocean acidity too. When carbon dioxide gets into the atmosphere, what happens is, when carbon dioxide gets into the ocean, what happens is it helps absorb it, as I said before, with the global warming. And what we're seeing is with the coral being destroyed is that the oceans are becoming more acidic because of the carbonic acid that CO2 combining with water is then releasing. And of course, that is a kind of a positive feedback where not only global warming is killing the algae in it, but we're also seeing increased acidity due to this global warming, and therefore more. The saltwater life zone is a little bit different than freshwater. Open sea, so we talked about coastal regions. Now the open sea, where you think about where all the sharks and things are going to live. This is after the coastal or continental drop. We have a couple different vertical zones, so vertical meaning up and down zones like this. The first zone is euphotic, of course, photic meaning light. In the euphotic zone, which is in the top here, where light can penetrate, and that can vary around the globe. We have lighted floating plankton, low nutrient levels overall, except at the upwellings, of course. And we do have high dissolved oxygen. The reason we have high dissolved oxygen is because we do have photosynthesizing plankton in there. We also have large, fast-swimming predatory fish, nekton in other words, things like swordfish, sharks, and tuna. Below there, so we have the euphotic zone on the top. Below there, we have the baffle zone, so we're talking in this region right here. Very dimly lit, so we got some light coming through, but not enough to do great photosynthesis. That's where we really don't have producers, but we have zooplankton. Zooplankton will come up by the producers and eat, and of course that's going to start a food chain where we have the phytoplankton up here, zooplankton's going to come up, and then larger fish are going to follow, and larger fish are going to follow, and so on, as part of our chain. The abyssal zone, or the abyss, is actually in the bottom of the ocean down here, benthic, of course, being the bottom. In the abyssal zone, we actually have 98% of marine species, believe it or not, which is unheard of. A lot of those, we don't even know what they look like, to be honest with you, because we know more about the moon than we do about our bottom of the oceans. Very little dissolved oxygen out there, but those species need to be able to adapt to that. We have a lot of chemosynthetic bacteria, and think about like Finding Nemo with the anglerfish. They live down there. What they eat is marine snow, it's called. So what happens is all that dead, dying, detritus material floats to the bottom, and they get that. Things like crabs and oysters and things of that nature are on the bottom. They're deemed deposit feeders because that food is deposited to the bottom. There's a lot of filter feeders like oysters. We have hydrothermal vents on the bottom of the ocean where life is said to begin, the whole primordial soup idea. That's where specialized bacteria feed on chemical nutrients. That's it for the second part of Chapter 7, and I'll continue with the last part of Chapter 7 soon.